Guys, I'm David Singer, and today I'm going to be teaching you lesson 17.3, combining transformations of quadratic functions. So hopefully by the end of this video, you will be able to solve and hopefully write quadratic functions out. So my problem is page 657 on number 7. Before we jump into this problem, I would like to show you a few things, a cheat sheet that I actually made for you guys to make it much easier and simpler. If you would like to write it down, it would help you when you solve these problems. So this is a regular quadratic function, except in place of a number, you would have a variable replacing it as the example. So you would have a, h, and k. X is always going to be there, and for a, you basically have a equals vertical stretch, which means when you have a parabola, when you're graphing, a vertical stretch would be more narrow, so you would have more narrow, and this is the vertex in a parabola. And also, if it was also a shrink, would mean that it is wider, correct? And the vertex would be at the bottom. It would be wider. So let me put wider here. So I have a little thing here. If a is greater than 1, then it's going to be a vertical stretch. In that case, it will get narrower. And in this case, if a is less than 1 and greater than 0, then you are going to have a shrink, which means your graph will be wider. Next, we're moving on to h. H equals left slash right. That means that h in this problem determines whether your graph is going to end up going left or right. Now finally, let's move on to k. K equals up slash down, meaning on your graph here, you will be moving, you will be moving either up or down. That determines what number it is. So, now let's get on to the problem. Our problem here is f of x equals 4 in place of the a, x plus 2 squared minus 3. So another important thing when you're graphing these, you always start here at this number, because this is your y-intercept. This is where your problem is going to start. So in this case it says negative 3. So we're going to go ahead and go down on the graph negative 3. So 1, 2, and 3. Let me switch pens so it's easier for you guys to see. 1, 2, and 3. That would be right here. Now this spot is not actually going to be on your finished graph. It's just there to help you set a reminder. So the next thing we're going to do is look at the 2, which is right here. So we have x plus 2. 2 is in place of h, and in our problem it is positive. So an important thing to do, or to notice when you are solving these, this right here, the 2, the x plus 2 is always going to be the opposite, so it's going to be x minus 2. So in that case, starting from where we had, which was at negative 3, we would be going over 2. So we would go 1, 2. And that's where our vertex would be. That is the first point on where we are. So after making that point, we go back up here to see what our a is. A determines the vertical stretch or shrink. So when we determine what the a is, which is 4, that's going to be basically be our slope. And our slope can't just be a 4. There has to be something under the 4 as the denominator. So we would go ahead and make that 1. So it would be 4 over 1. So when we graph this, what we want to do is start from where our vertex was, which is that last point. We're going to go up 4. So 1, 2, 3, 4. And then over 1. So you go over 1, and then you're at 3. Now we have to do that again, except go the other side. So now we're going to go, starting from the vertex, up 4 and to the right 1. 1, 2, 3, 4. Now over 1. Then finally, all we have to do is connect the dots as a parabola. Oops, sorry about that. And this is what our parabola looks like, except a little neater than that. And now you have finished what this problem was asking. So hopefully I taught you guys how to solve and hopefully write. Another chance, if you want to, you can write this down real quick. I'll give you a second for that. Sweet. Now, that problem, that example that I gave you, that's always going to help you finding out how you solve this problem. And in the end, you get this. This is your final answer when you are asked to graph a quadratic function. Thank you.